Welcome. We're going to go ahead and start here. Uh, Looking at polynomials, and we're comparing them to our integer values because there's some similarities. So for example, here's a way to write 132, which you could say is 1 times 10 squared plus 3 times 10 to the first plus 2 times 10 to the 0. When we compare that to a polynomial, we see that it's the same thing, but here we're using x squared, x, and x to the 0. Same thing when we do an addition. You could write this as x squared plus 3x plus 2 and 4x squared plus 5x plus 1. And then just like we've done in the past, when we add these up, we get 8x plus 3 plus 5x squared. It's the same rules we use with integers. Now, some other things on here that we can do are adding things graphically. So let's look at that. First, let's look at a couple of these functions here. Here's a linear function, and we notice the y-intercept is at 2, and the slope is 1, so 2 plus x. Here's another linear function. The y-intercept's at 1, and the slope is negative 1, so 1 minus x. Here you see the parabola, right? And you can see there's no stretch. Goes over 1, up 1, over 2, up 4, and so on. So it's going to be the parent function, but it's going to be minus 2, since everything is dropped by 2. And then this one here, you can see it's really similar. Let me get rid of some of this here so it makes more sense. You can see that it's a cubic function. If you're looking at a cubic function here, if you look at some of the points, for example, 1 squared is 1, and 2, or actually cubed, is 1. 2 cubed is 8. So there's a point at that if you go over 2 and you go up 8. Similarly, if you go over 2 and you go down 8, so that would be negative 2 cubed, you get negative 8. And that's because a negative times a negative times a negative is a negative, right? Also, negative 1 cubed will give you negative 1. But the thing about this, and you can see it's actually shifted over 2. So instead of being the parent function of x cubed, we need a horizontal shift to the right. You can see how it's shifted from the origin. So we're going to write that. So instead of x cubed, if we want to shift to the right, we're going to say that it's going to be x minus 2 quantity cubed. So that gave us some practice. And I'm not going to go through the addition for these, but I do think that some of the graphical stuff's interesting. So we'll take a look at this. If you're adding two graphical functions here, you can see, I've done a few points already, but let's say I want to add at this x value, I want to add this point and this point. So really, I've got 6 plus negative 3 equals 3. So I have another point at 3. I can do it on the other side. Let's say I have a point here and a point here. So I've got 5 plus negative 2 equals 3. And what you realize is that because both of them are linear and the slopes are opposite here, that you end up that the sum is a straight line function. Here's another one. We've got n of x, which is the green parabola, and we've got m of x again, which is linear. And if you add the point values, you can see what happens with the purple parabola here. There's one more over here. This is with the cubic function. Let's expand this a little bit. Whoa, there we go. All right, we can try a few values here. So we know there's a point here that's at negative 1 and another point here that's at 3. And so therefore 3 minus 1 is 2. You can look here at 0, and we look over here at 4. This is at 4. So now I've got a point here and here. Okay. Another one right here I can see, whoops, is at 1, and up above it is at 5. So 1 plus 5 would be 6. Okay, and yeah, so and I could keep doing that, and I could see a pattern here. Here's another one. This one is 1, 2, 3, 4, 5, 6, 7, 8. So it's at -8 and 2, so it would be at -6. Okay, so you can kind of see, let's do one more here. This one is at 8 and 6, so that one's going to be way up there. And if we connect these, like so, okay, you can see that it's stretching out that cubic function. That's kind of cool. You can do that with all the points. And then the other thing is subtraction. And let's look at the graphical here. So this one is L of x minus m of x. So L of x is the darker one here. And I've already plotted some points. This point, I've got one point at 3 and 0. So 3 minus 0 is still 3. Then I've got a point at 4 minus -1, which gives me 5. And another one at 3, 4, 5, and goes down to -2. So 5 minus -2 is equal to 7. So I can see a linear function starting to merge here. Let's do one more. Let's see. I'm up at 6 right here, and I go down 3. So 6 minus -3 is equal to 9. So therefore I go up another 2. And so you're starting to see a linear function here emerge here.